Thank you very much for visiting our channel today. We are again going to be solving a problem under reducible to variable separable, and we stated that when you have a problem where you need to reduce the equation to variable separable, you need to do a substitution. So if you did not see that video, go right now and check it out on our YouTube channel, Math Science Hub. And after you've watched that video, come back and learn how to solve this problem. So we are told to solve the differential equation dy by dx is equal to sine of x plus y plus cos of x plus y. So we go on to do the substitution. We have x plus y here, so x plus y. That means we are going to let, in this case, we let x plus y be equals to a new variable which we call t. Let x plus y equal to t. And then we differentiate both sides, right, with respect to the independent variable, provided the independent variable is x. So in this case, we differentiate both sides with respect to x. We have the derivative of x with respect to x is 1, plus the derivative of y with respect to x is dy by dx is equals to, and the derivative of t with respect to x is dt by dx. Good. And if you watch that video, we said that after we've done this, we have to solve for dy by dx. So we send this across. We have dy by dx is equals to dt by dx minus 1. That is the expression we have for dy by dx. And once we've completed that, what we can do is to replace in this equation, replace this value of dy by dx for this. So the equation is dy by dx, in this case is dt by dx minus 1 is equals to cos of x plus, or sine, sorry. So it's sine of x plus y is t. So sine of t plus cos of t. Great. So to solve this, we send this one across, and we are going to have dt by dx is equals to sin t plus cos t plus 1. And once we do that, we can separate the variables. So we consider this entire expression has to be a function of t, and then we separate. So we have dt by dx. In fact, we just multiply dx by this side. We have dt is equal to sine of t plus cos of t plus 1, all multiplied by dx. And then once we've achieved that, we can separate variables. So we divide both sides by this. We have dt over sin t plus cos t plus 1 equal to dx. Great. And as soon as we do that, we can integrate both sides. So we have the integral of dt by sin t plus cos t plus 1 is equals to the integral of dx. Great. Now you did calculus 2, and in your calculus 2 classes you were taught to integrate functions like this. How do you integrate this kind of expression? So to integrate this, we're going to use magic substitution, or we call it reaction substitution. In this case, I'm going to inform you that sin t is 2 sin t over 2 cos t over 2. This is a reminder. And then cos t is, the value of cos t is 2 cos squared t over 2 minus 1. So I'm going to replace these two values for sin t and cos t into this equation, into this integral, and try to evaluate the integral. So let's see what we have. We have the integral of dt over, so the value of sin t is 2 sin t over 2 cos t over 2. That's sin t, plus cos t is 2 cos squared t over 2 minus 1. And then we have a plus 1 right here. Everything should be equal to the integral of dx is just x plus c. So we integrate this side, and then we move on. So we are about to integrate dt divided by 2 sin t over 2 cos t over 2 plus 2 cos square t over 2 minus 1 plus 1. So this negative 1 and this positive 1 they are going to cancel out. And once they cancel out, we have the integral of dt all divided by, so here we rewrite this stuff as 2 cos square t over 2 plus 2 sine t over 2 cos t over 2. And the entire expression should be equal to x plus c. Great. Once we do that, we divide each term in the numerator and the denominator by cos square t over 2. So we have the integral of, in the numerator we have 1 over cos square t over 2 dt all divided by 2 cos square t over 2 sine square t over 2 this side all divided by cos square t over 2 plus 2 cos square t over 2 divided by cos square t over 2. And the entire thing should be equal to x plus c. Great. So let's simplify. You have sorry, you do not have a square here, so this square will be removed. So here you have to simplify this. 1 over cos square is secant square. So over here you have secant square t over 2 dt all divided by, here you have a cos t over 2 goes into here, you have cos t over 2 under here, and sin t over 2 divided by cos t over 2 is tangent t over 2. So you have 2 tangent t over 2 plus, then these are going to cancel out, you have plus 2. Great. Now, in this case, you are going to say let tangent of t over 2 be equal to some variable u. And then we'll differentiate both sides. Differentiate this side, you have 1 over 2 secant square t over 2 dx is equal to du. Great. So here we can factor out we can rewrite this by factoring out a 2. So this is equal to x plus c. Rewrite that, we have the integral of, and then we have secant square t over 2 dt all divided by, so we have a 1 over 2 here, 2 parentheses over tangent of t over 2 plus 1 is equal to x plus c. Great. And once you do that, this half will go up, so you have the integral of 1 over 2 secant square t over 2 dt all divided by tangent of t over 2 plus 1. And then when you do the substitution, because we've already done the substitution, we have du is half of secant square t over 2 dx. So I just want to replace that. This is equal to x plus c. So we have the integral of this entire expression over here, according to this substitution, is du. So you have du all divided by this entire expression is u. So you have u plus 1 is equal to x plus c. And then when we do this, integrating du over u plus 1, you have the ln of u. The ln of u plus 1 is equal to x plus c. But you know that u is tangent of t over 2. That's the value of u. So you have the ln of tangent t over 2 plus 1 is equal to x plus c. Great. But then you also know the value of t. According to our substitution, we said t was equal to x plus y. So you have the ln of tangent of x plus y over 2 plus 1 is equal to x plus c. And then at this level, we can take e on both sides and find the value of, we simplify this expression more than this. So we will stop here for the solution, but this is the procedure for reducing a particular differential equation to reducible variable in the form of separable variable. Thank you very much, and God bless you.